Hi, and welcome to another series on WebRTC. This time we're going to make one peer share desktop and the other peer control that desktop. My name is Amir Ishaq. We are going to use Electron as our client. We'll build the UI using React, and we are going to build the signaling server using Node.js. Basically, peer A will share desktop via WebRTC with peer B, and peer B will control the desktop of peer A remotely. This is going to be fun to build, so let's go ahead and start coding. But first, it's important to understand the inter-process communication in Electron, which is a key part of building feature-rich desktop applications. Because we want to capture desktop, the only way to get the list of desktops and their IDs is through main.js. So what we are going to do is that from main.js, we're going to gather all the screens and display them in a menu. And then when you click the menu item, let's say, for example, we have in the menu, we have 3 screens, 1, 2, 3. When you click 1, we'll send the ID of that screen to preload.js and then forward it to renderer.js. And then the code in renderer.js, we're going to call getUserMedia and pass in the ID and render the desktop on the UI. So for this communication, we use the context bridge within preload.js. To listen for messages from the main.js within preload.js, we use the IPC renderer. And to listen for messages in main.js from preload, we use the IPC main. And if we want to make a call from renderer.js to main, we go through the preload.js using APIs that we can define ourselves. And to make that call from renderer.js, we call the API using the window object, as we shall see in a bit. So let's now go and start writing some code. Okay, let's start by creating our React app. Let's call it control desktop. Change folder, and let's test our React app. Okay, it is working. Okay, so let's go ahead and start writing code. Okay, let's change the port that our React app will run from. Let's make it run on port 4000. Let's do a quick test. So it's running on port 4000. I'm going to use Electron Forge, so let's go ahead and install that. So the import has made changes to the package.json, as you can see here in the dev dependencies and the config. But you notice it has removed our React start script. So let's call this Electron. Let's make sure our React app still works. Okay, it still works. Now let's go ahead and create our Electron application entry point main.js, and I'm going to put it in the public folder. Before writing code in our main.js file, let's do a quick test of our main.js and make sure that the Electron app is actually going to run and execute this main.js. Let's just do a console, and then let's do npm run Electron. See, it's running, and it has printed out Electron is running. So we know at least our setup is correct. To start with, I'm going to import by using require from Electron. Then let's create a method that we are going to use to create our browser window. Let's make sure the React app is what is displayed on the Electron app. So we load the URL to where our React app is running from, in this case localhost 4000. And then once the main window is ready, we change its state to show. And I will also set position to 0, 0. Oh, I forgot. I should set this as const. And then when the app is ready, let's call create window. Okay, let us test our Electron app. npm run Electron. Okay, so the Electron app did load, position at 0, 0, but we don't see the React app being displayed here. So the problem is that React app is not running. So what we need to do is, let's stop this, go to another prompt, and let's have React running. Okay, so our React is running. Now let's go ahead and rerun the Electron app. Now we see the app is actually loading within the Electron app. It's still running on the browser. But I guess we should go ahead and make it such that it won't run on the browser, or rather the browser will not load, and we just get it on the Electron app. Let's do that. All that we need to do is in the package.json under the script start, add browser equals to none. Means when the React app is running, it will not open the browser. So let's go and start the React app. So it's running and we don't have a browser loaded. Let's go ahead and run our Electron app again. We have the Electron app running with the default React UI. Now, as we have seen, our intention is to create an app that captures the desktop and displays it on our Electron app. So let's go and do some changes to our React app. Let's open the app.js and remove this part. Let's add. And then later on, I will be displaying the X and Y position of the mouse on the canvas that is laid onto the application. So let's add that bit here. And because we are doing desktop capture, we want to get a stream from the Electron app and display it in a video component on the React app. So let's add a video component. Let's add the video ref at the top. And then we need to add an import. So how do we display a desktop on our video component? We first have to start from the main.js and call desktop capture. But first, let's go and add it in the import. And then let's call it down here after our create window has been called. I guess we should do it in here. We call the get sources of desktop capture and we pass in the types that we are interested in. It's an array, and then it will give us a list of sources. Let's go ahead and log the list here and see what we get. Okay, let's go and run. Our app is running, but we're interested in what is displayed in the console. So we notice here we get a list of sources. So we get a name. Let's scroll all the way up. So we see the name screen 1. This is the main screen, this one here. And then you have screen 2 and screen 3, and then the individual windows that are open, as you can see here. Okay, and the other things that are included is the display ID. For the windows, it seems to be empty string, but for the screens, they have the number that is included inside the ID. But for now, we are just interested in screens and not the windows. Let's look through the sources and display the source name. Okay, let's run again. So we see that we're getting a list of screens only, and we get the names displayed. Let's enter code to pick screen 1. Now, as we have seen, to send the source ID to the React app, which is the renderer, we have to first send it to the preload.js. So let's do that. And this is how we call it. So let's go ahead and create the preload.js file. And in here, we're going to require the IPC renderer and context bridge. So let's go ahead and use the IPC renderer to start with, because we are going to receive the source ID from the main JS. Okay, we need to declare the screen ID. And for the renderer, to be able to make use of this screen ID, we make use of the context bridge. So let's go and create that. We call our API something like Electron API, and we create the API. We return the screen ID to the renderer. Let's add a console log here. Make sure that we get the source ID on the renderer side. But for us to be able to see the printout of our source ID, let's go ahead and add a line to show the dev tools. Okay, now let's go ahead and test this. Okay, so we have our dev tools. Let's go and see in the console. So we don't see our source ID. Okay, so our preload is not receiving anything. So the reason for this is that we haven't really specified where preload is in the main.js file. So let's go ahead and do that. Let's enable path, and then we enter that in here, and that is web preferences preload equals to path.join dir name preload.js. Okay, let's go and test again. All right, and this time we get the screen ID. With that done, let's go and create a context bridge so that our app client can subscribe for an event when the screen ID is available. So we call the expose in main world of the context bridge, and we create our API entry point and define the API send screen ID. We receive a callback from the client, from the renderer, and then we just do the same thing as we've done up here, but then we just send to the callback. Okay, so in reality we don't really need that. When we receive the source ID, we'll immediately send it to the renderer. In our case, it's the app.js. Let's go and add code here. We'll do window.electron API.send screen ID. In fact, it's better to call get screen ID rather than send. So let's go and change it here as well. Okay, and then we're going to receive an event and our screen ID as a callback. So let's go ahead and print that out, and let's hope that it works. Okay, let's recheck. When main loops through the sources and gets our screen 1, it will raise an event or send this to the preload or source ID, and through the IPC renderer, we're going to send to the client, to our renderer. Okay, so let's test that this is actually getting here. Okay, so we actually got it in our render. We got the screen ID. Okay, so now that we have the screen ID, let's go ahead and get stream, pass in the screen ID. Obviously, we haven't created get stream yet, so let's go ahead and create. Okay, start with a try catch block. Then we create stream equals to navigator dot get user media and provide some properties. Audio equals false, video mandatory, Chrome media source ID is the ID we just received. Once we have a stream, let's call another method called handle stream. We haven't created it. We're going to create. First, we get the width and height from the stream. Get settings. Then we send the width and height to the main process via the preload, and then we set the SRC object of the video element to the stream that we just received. And then we play. Okay, so now we go and actually this should be set size, not set width. Okay, so we go to preload and create this set size. So I'll add it here, and we are getting the width and height, and we'll be calling the IPC renderer dot send to the main process and raise an event called the value we are sending is the width and height within contained in size. And then we go to main, and we're going to add the event right here. Okay. We extract the width and height from size, and then we try to resize our window. And we can turn on the animation. Okay, let's go and test, and hopefully everything is good. So it looks like we're getting an error. Okay, so let's go and update. Looks like I forgot media devices here, and in main everything seems okay. So let's go and try again. We're still getting an error. It's telling us get video tracks is not a function. Let's go see where we went wrong. Okay, so we need to wait for the get user media to come back with the stream. Okay, let's go and try again. Okay, so now we have a stream and the window has been resized. Let's go ahead and remove the resizing. Let's make it fixed. So let's just remove the part where we are resizing the window. So here it is. Let's just disable that. Okay, try again. Okay, so let's remove the dev tools. You can see here. We have the desktop displayed on the app. Okay, so that's good. Okay, let's now go and add a menu where we can list the screens. Let's go back to main, and where we are doing the desktop capture, get sources once. Now we don't send. Let's save them in a variable. Okay, we need to define that, declare it, and we need to declare that. So let's disable all this and go all the way up. Okay, so now we have available screens declared, and we're getting the sources, which are the available screens, and assigning them to the available screens. Okay, now let's go and create a menu. So create tray, and let's go all the way up here and create our tray. So I'm just creating the name of the app and a submenu with a role quit, which should take the default OS quit action. And then we're going to add our screens. Which will be the screens menu. Actually, this should be in here. Okay. Now we need to import menu. Okay. And then what we need to do is say menu dot set application menu and pass our menu. So let's go ahead and test this out. And we have a menu. We have the quit action, and on the screen we see the screens. I happen to have 3 screens. Now we're going to add some action. When you click screen 1, it will display screen 1. When you click screen 2, display screen 2, and so on. Okay, so let's go back to code. So we add an onClick method, which we call send selected screen, and we pass in the item. Okay, we haven't created this, so let's go ahead and create it here. Main window dot web contents dot send set source, or set screen if you want to. Maybe just be consistent, and we send. Okay, now seems like complaining we haven't declared main window, because we actually have it, but it's inside the create window here. So what we're going to do is remove the const and we declare it outside. Okay, and then we have to go to preload and create the event there for set screen. Okay, actually we already have it. It's set source ID, so we're just going to use what we have here and then just pass in the ID instead of sending the whole item. Okay, let's go and test. Okay, and we go to screens, select screen 1. Let's close the DevTools. Select screen 2. And let's select screen 3. So we can switch between the different screens. So far, so good. Just for the sake of it, if we wanted to include the windows of applications running, we can go here and add, for example, window to be included. And we go ahead and run our Electron application again. This time, our menu should have both screens and windows. Now I could select, for example, OBS that I'm using for recording, or I could select just the command prompt that we're using, or I don't know. Yeah, so I can switch between screens and windows. Okay. To finish this part 1, let's just go ahead and add a little CSS. Actually, in index.css, let's just add for video. So we're using class name, so let's make sure it's a dot. All right, let's go and test. Okay, close the DevTools, open screen. Now it will fit within the width and respects the aspect ratio. Okay, so this concludes part 1. In part 2, we are going to try and render the video within a canvas, because we need the canvas to capture mouse activity and send it back to the server so that we can hopefully control the desktop. Thank you for watching and hope to see you in the next video. Bye.